Hi everyone, welcome to Ace with Ease. Today we're going to be looking at how to find the equation of an exponential function if you are given, or when given, an asymptote, a y-intercept, and another point on the graph, on the exponential graph. Okay, so there are several steps or few steps that you need to follow. Okay, the first step that you need is to sub the asymptote into the standard equation. Okay, and from there you're going to sub the coordinates of the y-intercept into the standard equation that you have already subbed the asymptote, okay, in order to solve for a. Okay, and from there you would substitute the asymptote, the value of a that you would have calculated at the second step, and the coordinate of the other point, okay, into the standard equation in order to be able to solve for the b. Okay, so let's look at an example. Okay, so we're given this function here. It's an exponential function, it's a decreasing function. Okay, it is an asymptote at the point y equals to 1. It has got a y-intercept at a point 2, so the coordinates of them y-intercept are 0 and 2, and it is another point -1 and 4. Okay, so that's what we have from this function. Okay, so we are trying to find the equation of this line or of this curve. So what we need to do, firstly we have to substitute the asymptote into the standard equation. So our asymptote is y equals to 1, or y equals to plus 1. Okay, so which is what we did. This is our step 1. We just substituted y equals to plus 1 or plus 1. Okay, so we're done with the first step. We just substituted the vertical asymptote. From there, the step 2 says that we should substitute the coordinates of the y-intercept, of the y-intercept into the equation that we had from step 1. So from step 1 we have this equation, y equals to a b to the power x plus 1. Okay, so we just substitute the coordinates of the y-intercept. Okay, so the coordinates of the y-intercept is 0 and 2, so y is 2, we put 2, and x is 0, we put 0 there. Okay, so we'll have 2 equals to a equals to b to the power 0. Anything to the power 0 is 1, that's why we have 1 there, and then a times 1 is just a. So from here we just solve for a, we take this 2 to the other side, it becomes 1, and we have a equals to 1. Okay, so now we are done with step 1 and step 2. Okay, now step 3 says that we must substitute, okay, basically the asymptote and the answer that we got in step 2 and the coordinates of the other point on the graph. Okay, so our asymptote is plus 1, and the answer that we got in step 2 is 1. Okay, it's the value of a is there. Okay, and the coordinates of the other point. Okay, the coordinates of the other point, x is -1, we put it there, and then y is that. So from here we'll just solve for b. Okay, and then after getting b, it means we have got all the components of our equation of the exponential function. Okay, so now we can write the equation in full as, okay, y equals to 1 times 1 over 3 to the power x plus 1. Okay, but in most cases you don't really have to write the 1. You can just write y equals to 1 over 3 to the power x plus 1. Okay, that is acceptable. Okay, so let's look at a second example. Okay, so in our second example, okay, we have a function again. Okay, we have an asymptote at a point y equals to -1, and this function has a y-intercept at a point y equals to -2, and there's also another point on the graph 1 and -4. Okay, so how are we going to find the equation? We'll apply the very same steps that we did in the previous example. And okay, so what is the first step? The first step would be to substitute the asymptote into the standard standard equation. So when we substitute the asymptote, we'll have y equals to a b to the power x minus 1. Okay, so that's the first step, and we're done. Okay, what would be the next step? The next step would be to substitute the x, the y-intercept, the coordinates of the y-intercept. Okay, so which is 0 and 2. We substitute 0 and 2 into this equation that we just got in step 1. Okay, then y is negative 2 and b is 0. So we'll have negative 2 equals to a b to the power 0 minus 1. Okay, but we know that anything to the power 0 is 1. So we'll have negative 2 equals to a times 1 minus 1. Okay, so a times 1 is a, and then take a times 1 is a, and then take the minus 1 to the other side, it becomes positive. Then your a becomes negative a. Okay, negative 1, excuse me. Okay, so from there we'll go to step 3. Step 3 says you must substitute the asymptote and the value that you got for a, and also the points, the coordinates of the other point of the graph. Okay, the coordinates of the other point on the graph is 1 and negative 4. So y is negative 4. Start by putting negative 4, and then we put negative 4 where there is y, and then the x we put 1. That's why we have 1 here. And then the value of q, the q is negative 1. It's fine, negative 1. And then a is negative 1. It's negative 1 there. Okay, and then we solve for b, and we get our b to be 3. Okay, now we have got all the components a, b, and q. Okay, so we can substitute into the standard formula, and okay, our a is negative 1, so we can just write negative, and then our b is 3, and our q is 1. So it means that eventually our equation will be y equals to negative 3x minus 1. Okay, this would make sense because firstly the graph is under the vertical asymptote, so you expect the a to be negative, so which makes sense. Okay, so guys, I hope this was helpful, and yeah, you're gonna ace it when you find it in a test. And yeah, that's it for this video. If you haven't subscribed, please subscribe. Okay, comment, okay, and like the video. Okay, thank you guys for watching.